This particular concept is very important to the types of bonding and characterizing the types of bonding for atoms. Electronegativity is the ability of an atom in a molecule to attract electrons to itself. A molecule or an ionic compound. So the atoms basically are not created equal, do not have the same desire or proclivity to attract electrons to itself. And some atoms, like fluorine, have a really high electronegativity, and then some atoms, like cesium, have a really low electronegativity. And so that means if you bond cesium and fluorine together, you'll find that the electrons will actually be pulled towards the fluorine and be pushed away from the cesium. And so what happens is sometimes that means there's an ionic bond that occurs, sometimes it's a covalent bond. But if it's a covalent bond, even though the electron is not completely removed from the cesium, it'll spend most of its time and be much closer to the fluorine than it would be in the cesium atom. Notice the trend here that as you go from left to right on the periodic table, your electronegativity of the atoms increases, and as you go from bottom to top, the electronegativity increases. Notice also that the noble gases aren't shown on here. They have very, very low electronegativities because they don't actually want to attract electrons to themselves. Why don't they want to attract electrons to themselves? Their valence shells are full. So they don't even want any more electrons because they'll have to put that electron into a higher quantum number, principal quantum number, because their electron shells are full. So again, if you're looking at the different, and the way to calculate electronegativity difference is by, of course, subtracting the higher value from the lower value. So if you have something like hydrogen and fluorine bonded together, the difference between those two is very important when we get to characterizing whether it's a covalent or ionic bond, when we get to predicting those types of bonds. So for covalent bonds, you have this idea of unshared of sharing electrons. But when if it's in a covalent bond, if electrons are being shared in a covalent bond, sometimes the electrons are not shared equally. And in fact, this occurs most of the time. Only in species where you have the same types of atoms being bonded together do you have equal sharing of electrons. In all other species, the electrons are not shared equally. So in the case of hydrofluoric acid, you get a much higher electron density over here on the towards the fluorine than you do towards the hydrogen. And this is because of the difference in electronegativity. The fluorine pulls more of the electrons than the hydrogen does, and so the electrons are essentially much closer to the fluorine nucleus than the hydrogen nucleus. Bond polarity is a description of electrons being unevenly shared. And what happens in this case is you get a partially negative charge on the fluorine and a partially positive charge. Now, it's not a fully negative, fully positive charge if it's not an ionic species. But how do you know if it's an ionic species or not? Well, there's actually a series or different types or scenarios that can occur when you have atoms bonding together. You can have nonpolar covalent bonds. So nonpolar covalent bonds are bonds between electrons between atoms that the electrons are shared equally or very close to equally. You can have polar covalent bonds. And polar covalent bonds are electrons where one of the atoms has a larger electronegativity than the other atom, and you get an unequal sharing of the electrons. And finally, you have an ionic bond where one of the atoms just goes over and takes an electron from another atom. Okay, so one of the atoms is taking an electron, the other one is giving it up. It's donating it. So it's not a violent act, but it's there. Anyway, so how do you know whether or not they fit into these different categories? Well, you look at the difference between electronegativity for those atoms. If the difference is between 0 and 0.4, Okay, so the difference from this last chart, let me show it again, is between, so like the difference between fluorine and chlorine, that would be a difference of 10, right? Or excuse me, 1. 4.0 minus 3.0. So if the difference is between 0 and zero point 0.4, we consider that a nonpolar covalent bond. Okay, so even if it's 0.2, they're not being shared exactly equally, but it's a negligible difference in electronegativity. If the difference is between 0.5 and 1.9, we consider that a polar covalent bond. So one of the species has a partially negative charge, one of them has a partial positive charge. The species that is more negative has a partial negative charge. And I'll show you how to actually designate that in a later part. And finally, we have electrons that are actually taken by one of the species. And that happens when the electronegativity difference between the atoms is greater than or equal to 2.0. Okay, so if the electronegativity difference is greater than or equal to that, it tends to form an ionic bond.